Hey guys, I'm ready to go. So here we go. We're going to start with the notes. So we're going to start with an exploration. It says the distance a baseball travels after it is hit depends on the angle at which it was hit and the initial speed. The table shows the distances a baseball hit at an angle of 35 degrees travels at various initial speeds. So in the table you see x is in miles per hour and y is the distance in feet. So in letter A it says, recall that when data have equally spaced x values, you can analyze patterns in the differences of the y values to determine what type of function can be used to model the data. If the first differences are constant, then the set of data fits a linear model. We did this when we did our arithmetic. If the second differences are constant, then the set of data fits a quadratic model. So what I want you to do, and if you'll take out your graphing calculators if you don't already have them, it looks like most of you do, which is fantastic. But you'll need your graphing calculators for what we're going to do is I want you to find the differences between the y values. And in order to do that, you're going to take the second y value minus the previous one. So you'll take 220 minus 194, so that's 26. Then you'll take 247 minus 220. And so on. So find each of the differences. Now you notice when I take a first difference, they're not the same. But if I go and then take a second difference, it is constant. So if I go to a second set of differences and it is constant, this is quadratic. That means it's a second degree polynomial. So now I'm going to pull up my calculator on the screen for you. And part B says, using your graphing calculator, we're going to find a model for the data. So I need you to really stay with me here. So when I put the steps on here for you, so you're going to open a new document. Okay, open a new document and then go to number 4, add lists and spreadsheets. So you actually did this last year in Algebra 2. So we'll do a quick refresher here. Then you're going to go up to the tippy top where letter A is, and you're going to put an X. Then you go down to the number 1. Yeah.
Do you have any of those like battery packs?
I do. If you can bring me your cell phone, I'll trade you. This way I will get it back. Because I lost one when I blown it. Just to set it right here is fine. There you go. All right, so I'm going to enter the x values, 80, 85, 90, 95, and so on. And then you're going to go to the B column. We'll call it y, and let's enter the y values. So let me talk through the steps one more time. You open a new document, select number 4, add lists and spreadsheet. You enter the data, but you have to label the column as X and Y. Okay, now you go to an empty cell. Okay, go to an empty cell below. And what you're going to do is you are going to press Menu. Number 4 is statistics. Number 1 is stat calculations. Oops, I keep doing that. Let me try it again. And then this was quadratic, right? So we're going to go down to quadratic regression, and we have to tell it that the x list we called x, the y list we called y. Arrow all the way down to OK. And then what you have to do, and you need to make sure that you do click on the cell with the A value and the B value, because sometimes it's like a long decimal number that you can't see. So you want to make sure that you are getting it accurately. So here's my model. Y equals 0.02x squared plus 1.9x minus 86. Okay, anybody need help with the buttons and doing the regression? Is this coming back to you from last year? All right, when you're ready, flip the page and we're going to answer 2 questions. Yeah.
Wait, so when we go into stat calculation, which
Yes.
one do we pick?
Well, you remember we determined it was quadratic,
So you
right?
pick quadratic?
Yes. So like if it were first degree, it would be linear. What would you choose if it's third degree? Cubic. Okay. Yeah. So it depends on what you get. All right. Again, when you're ready, flip to the letter C. Using your model in part B, find the distance a baseball travels when it is hit at an angle of 35 degrees and travels at an initial speed of 120 miles per hour. Okay, so use your information and plug in what you know. All right, so what did you have to do here to figure this one out? Yeah, Maria? Exactly. Okay, all you had to do was plug in 120 for x, and I got about 430 feet. Do make sure on word problems that you're asked that you include appropriate units. Letter D, according to the baseball almanac, any drive over 400 feet is noteworthy. A blow of 450 feet shows exceptional power, as the majority of major league players are unable to hit a ball that far. Anything in the 500-foot range is genuinely historic. Estimate the initial speed of a baseball that travels a distance of 500 feet. So this is the y value. And what we're going to do, this is quadratic. I can subtract 500 from both sides of the equation. And you can either do quadratic formula, or we can use that real polynomial zero function where you press menu, algebra, polynomial tools. Do you remember that one? I do want to emphasize that you should be able to do quadratic formula. If I sometimes give you a quiz or a test and I might say only red OGT calculator, so make sure you do know how to do quadratic formula if you needed to. Alright, make sure you know how to do this. I got 130.14 miles per hour. So that's pretty amazing. Alright, properties of finite differences. If a polynomial function y equals f of x has degree n, then the nth differences of equally spaced x values are non-zero and constant. So what that means is that I can't get 0, 0, 0, 0 across as a constant. Now, it's okay to have like a difference of 3, a difference of 0, a difference of 6, a difference of 7, a difference of 0. That's okay, you just can't get 0, 0, 0, 0. There's something wrong with that. Alright, conversely, if the nth differences of equally spaced data are non-zero and constant, then the data can be represented by a polynomial function of degree n. So let's take a look, and I did these three for you. It says, if f of x is 5x plus 3, if I go ahead and do the differences, I got 5, 5, 5, 5, 5. So this would be degree 1 or linear. If you look at the second one, where f of x is x squared plus x plus 3, I did the first differences, and then I did the second differences, and they were constant. So it's quadratic. And if you look at the third one, which is a cubic, f of x equals 2x cubed plus x minus 10, it went down to the third difference until they were constant. Okay? So now, let's do one together. It says, using the same method as above, find the degree of the polynomial given the table of values. So we're going to go ahead and do the differences. This is down 3, down 3, down 3. So this is linear. Okay, linear is your first degree, quadratic is your second degree, cubic is your third degree, and so on. Now it says find a polynomial equation that models the data. I want to go ahead and show you, you really shouldn't do regression for linear, because that's a real algebra 1 level that we should be able to do. The common difference is m, and then I pick any point x comma y, and I'm going to do point slope. So this is a good refresher for us on point slope. So remember, again, the common difference on a linear is the slope. And we did that with arithmetic, right? This is a nice connection to arithmetic. That's why this is in this chapter. So this is y minus 2 equals negative 3 times x minus 1. And then I add 2. And here's my equation. Y equals negative 3x plus 5. All right, you guys try the next one that says problem 1. Find the degree by doing the differences. Then come up with the equation. Alright, so when I did this one, I noticed I went up 10, up 14, up 18, so it's not linear, and then it went up 4 and up 4. So this is quadratic, or second degree. And then I got y equals 2x squared plus 4x minus 8. Are we getting it? You guys get it? Yes? Yeah. On this one?
Yeah.
You do it on regression, yeah. Just linear, I'd like you to do by hand. You could do quadratic, right? Couldn't you do a system of equations? It would be 3 equations, 3 unknowns. We did do that in Algebra 2 last year. All right, when you're ready, try problem 2. Okay, when you're ready, try problem 2. Find the degree by doing common differences. And then use your calculator and regression model to come up with the equation. So you now know everything. This is the last new material for the test on Friday. So tomorrow we'll just do a little bit more work on this, start some test review, and then Thursday the whole period will be for review.
Is there any way to get it so when you put in X and Y, like old stuff?
You just have to type over everything. Are you getting that it's cubic? Are you getting a 3rd degree? Okay, awesome. Keep in mind, if I just gave you a sequence, I don't have to give you 1, 2, 3, 4, 5, 6, because those are implied. When you get it, check yours with the board. The part B, find the equation of the polynomial that models the data. I got y equals 3x cubed minus 2x squared plus 3x minus 10. You guys getting it? So not too bad at all. When you're ready, problem 3. Now I'm going to ask you to kind of think it through, apply what we've been doing. In problem 3, it says suppose f of x equals mx plus b. In letter A, I ask you to calculate f of 5 minus f of 4. So go ahead and try that if you understand what to do. So f of x is mx plus b. So I want f of 5. So this is really going back to some Algebra 2 and some Algebra 1. What does it mean to compute f of 5? Like just in general, what does it mean? Yes, okay, you're going to plug in 5 is x. That's it. Well, I don't know m and I don't know b. So this is going to be 5m plus b. And if I want to do f of 4, that I'm going to replace the x with 4, and it's going to be 4m plus b. So what I'm asking you to do now is to take f of 5 minus f of 4. Well, you need to be careful because f of 4 is a sum, and I'm going to have to distribute the minus sign. So 5m plus b minus 4m minus b, what does that equal?
M.
It's m. Now I want you to stop and think here, because I'm going abstractly to see if we really do understand what's happening. 5 and 4 are 2 consecutive terms, right? And if it's linear, what does the m?
Slope.
It's the slope and it's the common difference, right? It's the common difference in a linear sequence. All right, so that's part want you to do f of x plus 1 minus f of x. Well, it shouldn't bother you to do f of x plus 1 because it's the same thing as f of 5 or f of 4. You're going to replace x with x plus 1. So that's going to give me m times, and I'm replacing x with x plus 1. So that's mx plus m plus b. F of x is mx plus b. So very carefully subtract. So I'm going to do mx plus m plus b, and I'm going to be proactive, and I'm going to subtract the mx and the b. What happens? Okay, now this connects to part C. What is happening with f of x and f of x plus 1? Aren't those consecutive terms again?
Yeah.
And so for part C, this is giving it to me in general. This is saying that no matter what x I choose, if I take the difference between the one beyond it, x plus 1, and the one before it, x, that difference, if it's linear, and f of x equals mx plus b, that is linear, right? That's a line. I'll always get that. All right, the next one. The dot patterns shown are pentagonal numbers. The number of dots in the nth pentagonal number is given by, and that's an explicit formula. Show that this function has constant second order differences. So that just means find their differences. So this is up 4, up 7, up 10, up 13. So it's definitely not linear. But when I go and do the second, it's second degree because it has a common second difference. All right, what I have is the last one. This is a challenge. We're actually not going to take time in class to do it, but it says if f of x equals ax cubed plus bx squared plus cx plus d, find f of 1, f of 2, f of 3, up to f of 6. Prove the third differences of these values are constant. I know that some of you are coming in from Honors Algebra 2, so I want to make sure that I am challenging you and making sure you get to enjoy some higher order thinking. I worked it out, if you do want to check it, but it took me over half of the back to do that challenge problem. So it is fun. It is definitely fun. But do that if you are inclined. So what I want you to do now is I want you to take out your laptops and I want you to go to Schoology